Alright, hey y'all. So today's lesson is Trig Intro. So I'm going to go over the trigonomic functions and show you how to use them to solve problems. So just some information. The trigonometric ratios are sine, cosine, and tangent. You've probably heard of those before. Sine, cosine, and tangent. On your calculator they look like this. And when you use these trig functions, it's all about the angle measurement. So we're going to be dealing with triangles, and it's when you, like, let's say you wanted to talk about sine, you would have sine of some sort of angle measurement. Now, the way that you've heard of angles have been in degrees. That's one way to represent an angle measurement is degrees. But there is another way that's called radians. Your job right now is only really with degrees. I'm going to show you briefly radians, not extensively. I'm just going to show you how to do that. But our focus is going to be with degrees. So the first thing you want to do is you want to change the calculator mode to degrees. When you turn on your 83 and you press mode, it is defaulting to radian. And what you're going to do is you're going to change that radian to degree by highlighting it and pressing enter. If you do not, then when you try to solve these problems, you're going to come out with the wrong answer because your answer is going to be in radians and not degrees. So to evaluate, you just type it in your calculator, sine of 52. I've changed my mode to degree. And then I'm going to hit sine and 52. And when I do that, I come out with a decimal, and it's going to be 0.788. Cosine of 122 degrees. So I'm going to hit cosine of 122, and I get negative 0.53. And again, I've changed my mode to degree. Tangent of negative 76 degrees. So you hit tangent of negative 76, and it's negative 4.01. Now, if you have a problem and it doesn't have a degree sign, unless the directions explicitly say every measurement is in degree, if you have a tangent of 5 and there's no degree sign, then it could possibly be talking about radians. And then you would have to change your mode back to radians. Then you could type in tangent of 5, and it comes out to be negative 3.38. If you typed in the degree, so if you typed in tangent of 5 degrees, then your answer is a different decimal. So you have to pay attention if it has the degree sign or if the directions explicitly say degrees only. And occasionally when you're finding the evaluating, sometimes your tangents are not going to have a solution, so that means they're going to be an asymptote at that number. If it comes out and it says error, then that's probably a no solution to that equation. Now, if you have an equation, you have to use the inverse, just like we've talked about, the inverse equations. So the sine, cosine, and tangent all have an inverse. And remember when we studied inverse functions, we had that little -1 exponent, which made it denoted that it was an inverse function. So the sine, cosine, and tangent inverse has the -1 exponent. And to solve an equation, you have to use the inverse trig function. So if you have an equation, sine of x is equal to 0.6. Now I'm letting you know that all of these are, the purpose of these is degrees. So go to mode, change it to make sure it's on degrees. It is. Sine of x is equal to 0.6. We want to know what angle measurement would that be right there. So we would have to use the inverse, so we would type in our calculator, sine inverse of 0.6. And that in your calculator is going to be the second function of sine. So second sine of 0.6. And then the answer is, so your final answer, x equals 36.87 degrees. That would be your answer. Number 2, cosine of x equals 1.5. So to solve it, it would be the cosine inverse of 1.5. We are undoing this equation. So the cosine inverse, second cosine of 1.5, and it says error domain. So whenever you get that, that means there is no solution. And sometimes over here, for some sine and cosine values, you're not going to have a solution when you're doing the inverse. And that's fine. Number 3, tangent of x equals negative 6.7. So the inverse tangent of negative 6.7, you would type in the inverse tangent of negative 6.7. Oops, negative 6.7. And you would get negative x equals negative 81.51 degrees. And number 4, because we're trying to solve for the angle, it would be cosine inverse of negative 0.87. So the cosine, the inverse of cosine, negative 0.87. And x is going to equal 150.46 degrees. Now I'm rounding. So if you are trying to find the angle measurement and it gives you the answer, you're going to use the inverse trig function. Alright, so copy this down. The uses of trig functions when we have triangles. So a couple of information. To name the angles, we're going to use the letter like A, B, or C. Or possibly we'll use the theta. This is the theta symbol. Or an x. So sometimes it's going to say the sine of theta or the sine of x. Or it might just say the sine of A, B, or C. The ratios of side lengths with the angles. And so that's the whole purpose. We're going to use these ratios of side lengths. We have leg A, leg B, and hypotenuse C. The hypotenuse is always the longest side. A and B are always the shorter side. So we're going to end up doing a setting of ratios of using our legs and hypotenuse. Always look from the perspective of the angle. When you have a trig problem, it's going to ask you to look from an angle, and that is your starting point. That is the perspective you look from. So if this problem asked about C, then we would want to look from the perspective of C. Not B or A, but C. So you always want to make sure you understand where the angle is you're starting from. And there are 3 sides when we talk about the triangle. The hypotenuse is always this longest side, the hypotenuse. And then one side is called the opposite, one side is called the adjacent. And you can't say that it's always going to be a certain side because it depends on your perspective. Let's take this triangle down here. This is angle X. If I asked you what was opposite angle X, then the opposite would be 3. If I asked you what side was adjacent to angle 4, if I asked you what side was adjacent to angle X, the answer would be 4. Adjacent means beside. So from angle X, this is opposite, and from angle X, this is adjacent. Now, from the perspective of angle theta, here's angle theta. If we were at angle theta and I said what's opposite of angle theta, the opposite would be 4 because it's opposite. If I asked you the adjacent to angle theta, then that would be 3. So it all depends on what perspective you're looking at. Okay. And now here is the meat of it. Here are the ratios. Sine is always the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And tangent is the ratio of the opposite side to the adjacent side. And I wrote right here, SOHCAHTOA. SOHCAHTOA. That's what some people say, SOHCAHTOA. And what that stands for is sine is, sorry. All right, now it's better. SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So some people will learn SOHCAHTOA. A phrase or a sentence that some teachers will tell you is this. Oh, heck, another hour of algebra. Oh, heck, another hour of algebra. So you can have SOHCAHTOA or the phrase. Either one, you have to remember sine, cosine, tangent, and the ratios. So here are some examples. If I asked you for number 1, the sine of A, I want to know what the ratio is for the sine of A. So if I look at this triangle, I'm looking, my perspective is A. Sine is opposite over hypotenuse. So if I'm at A, the opposite side is 12. The hypotenuse is 13. And that's all we're going to right this second. The cosine from A, so again we're starting with A. The cosine is the adjacent side to A, so 5. And the hypotenuse, which is 13. Now, tangent of theta. You have to find angle theta. Angle theta is here. Tangent is the opposite side. So theta, the opposite would be 5. And the adjacent, which is 12. Number 4, cosine of C. So we're starting from angle C. Angle C and angle theta are the same in this problem. So the cosine is the adjacent. So the adjacent to angle C is 12. Over the hypotenuse, which is 13. And then the sine of angle theta. So again, we're starting with theta right here. Sine is opposite. So the opposite of theta is 5. And the hypotenuse is 13. And then if we wanted to, we could use the inverse functions to find the angle measurements, but we're not doing that at the moment. So after watching this, you should know how to evaluate sine and cosine on your calculator, the inverse of sine, cosine, and tangent, and now the ratios of sine, cosine, and tangent.